in agentic systems. And good example of this is Lemonade AI, which is an insurance company. It's claim processing. So they kept an agent, and their agent it's able to process 30% of their claims in less than 3 seconds. It does everything: cross referencing their policy terms, fraud detection, and authorization. Everything. And the industry standard today is approximately 3 days, but their agent it's just 3 seconds. This is a different class of business and classic example how you can scale with AI. Now, a common thing is that when you say an agent, we are able to understand what it is, but how does it truly work? When we are talking about an agent, there's a cycle and loop. And an important concept that occurs here is that we have self-correction. In the projects earlier, before AI and agentic AI, we usually had exception-based or fast-fail systems. But using agentic AI, we're able to have self-correction. And this is a loop, where first we have decomposition, where we use React tree of thought, chain of thought methodologies to break down the goal into subtasks. And a common failure that occurs in multiple places is that these agents take lots of time for just planning. So you must set a depth limit so that they don't run out of context window before their planning is done. Secondly, we have execution and interaction. This is where, as I told you earlier, the agents interact with their entire environment to process and complete the goal. And then we have reflection and reaction. This is where we take in the output of the agent of what it did and checks whether I completed or satisfied the goal. For example, is the data that I got credible? Is it accurate and reliable? And based on this, it will plan its further strategy. What further steps I need to do. Say I don't have data available, so where should I get it from? Now, as we scale from single agents to multiple agents, in companies we see three major flows. So the first one of multi-agent flows is sequential, where the output of agent A is passed to agent B and so on. So this is best when you have a linear change defined. And the output from this, it's clean and predictable. Then you have the hierarchical manager workflows. So given a goal and it assigns each goal to multiple agents. Each agent would be specialized in whatever function it is performing. And at the end, the output is again synthesized and passed back to the user. And lastly, we have the iterative or round robin. Over here, the agents discuss among themselves till they reach an fallible output. For example, a generator agent produces something, but a critic agent criticizes it, say it's not compliant with something. The major hurdle over here is that every interaction between them is a full LLM call. Say you have 5 agents and 3 iterative reflection circles, that's approximately 15 to 20 cycles of LLM calls. Now another thing is that these agents, they might disagree. For example, when the generator agent produces something, the critic agent may not accept it. And if you don't keep a proper termination condition, you might enter an infinite loop and waste money in API calls. Now, coming to AI, we must all be responsible and have some ethical guidelines regarding it. And three of the major challenges that companies usually face are firstly hallucination. And hallucination, it is a really common part that occurs and it has to be mitigated before going to production environments. There are multiple ways that we handle hallucination. Some of the most common ones are firstly verification architectures, where one agent checks the other agent. And secondly, we also have RAG pipelines. So in chatbots using RAG, what happens is the data is sourced from your own indexed data. So that is a previous pipeline that happens, and the agent gets it only from your data, and it pinpoints where exactly it got it from, the exact line that it got it from. And when that data is not provided, it cannot be taken as fact. And secondly, you have bias. This is an problem that needs to be corrected from the start using audit-ready data pipelines, right? From audit-ready data pipelines. So you must conduct checks across demographic segments from your training data onwards. If you do not know what's in your training data, the biases in your training data, then you can't know what output the AI agent might give you. And lastly, we have over-dependence, which is a leadership trust. It is. At the end of the day, as the human, you should be the person who is gonna ensure that this decision should be in your hands or whether you can delegate it to an agent. The time when the humans will not be involved, that is, you do not take care of it, you do not ensure that the taken decision is the correct one or not, if you don't verify it, that's the day your company is headed for doom. And lastly, I'd like to end this session with an observation that's been with me the longest. The gap right now is not a technological gap. We all have the same models at the same cost per token cost, and we have the frameworks open source. The gap is in clarity gap. The clarity about what problem needs to be solved, what decisions should be taken by humans, and which ones can be taken by AI. This gap, those who will overcome this and move forward will grow at an exponential pace. So through this session, I try to give you a map regarding what the future can look like. And what you do is up to your hands. Thank you for your time.